Hello and welcome back to the course on R programming. I hope you had a chance to play around with the matplot function and that you were able to create some impressive charts. And as you can tell, it's getting pretty exciting already. We're working with charts, we're looking at the basketball data. What's coming up next, right? So what we're talking about today is subsetting. Subsetting is a very important topic in R, and actually a lot of R users get it wrong. In fact, some R programmers can go for years without knowing exactly what subsetting is and how it works, thinking that they do know it until they run into a problem one day, and then only they find out about subsetting. So today I want to make sure that you will never ever end up in a situation like that, and that's why we're going to get this topic down pat. All right, so let's go to a new file, and the way I want to introduce this topic is through something you already know. So we've already talked about using the square brackets with vectors. So let's create a vector, and in that vector we'll just put 5 values, just 5 letters. And if we run this vector, there they are, those are our 5 letters. Now we know that if we want to extract just the first and the fifth letter, then to do it we need to type in x, square brackets, then c, 1 and 5. Because c, 1 and 5 is just the values 1 and 5, and this over here tells R that we want to extract the first and the fifth value from this vector. All right, great. So if we want to extract just one value, if we want to extract just the first value, then we would do a similar thing. We would type in x, square brackets 1. And we're pretty comfortable with that already. Now, the interesting thing is that what we're actually doing is we're actually subsetting the vector x. Right, so originally we had a vector of 5 values, then we have a vector of 2 values, and finally we have a vector of just 1 value. And we know that this is a vector because we've talked about that in R, even a single variable is stored as a vector. Okay, so every time you subset a vector, you get a vector. Great. But now let's look at a similar concept with matrices, because you can also subset matrices. Let's say we look at the games matrix that we've been using so far. And these are the games that the players have played. Now let's say we want to look at just a subset of this matrix. Let's say we want to look at the first 3 players, or the top paid players in the NBA, Kobe Bryant, Joe Johnson, and LeBron James. And we want to look at their stats, or the number of the games they've played, only for the past 5 years. So 2010 to 2014. How would we write that? Well, it would be very similar to what we've been doing with the vector. We would type in games, then we would put in square brackets, and then for rows, so there's our comma, for rows we would say 1 to 3, and for columns we would say 6 to 10. So if we run that, we get the first 3 rows and the 6th to 10th columns, exactly what we wanted. And this time it looks like the subset of a matrix is also a matrix. Great. Now let's try another example. Let's say we want to compare the top paid player in this list and the lowest paid player in this list, Kobe Bryant and Dwayne Wade. So how would we do that? And we want to compare them across all of the years, the number of games that they've played. Well, the way to do that is to say games, and then in square brackets we would say C, 1 and 10, right? So we want just the first and the 10th rows, and then for columns we just leave a blank. And we've also talked about that if you want to select a certain row, then you just type in the row number, comma, blank in the square brackets. And that's exactly what we're doing. We're just selecting 2 rows here. If we run that, we get the first and the 10th row. And once again, we get a matrix. And one more example like that would be if we want to select, let's say 2008, 2009, we just want to analyze those 2 years and for all of the players. Then we would say games, in square brackets we would type in blank, comma, C, and this time instead of counting out every single column, we would just type in the names of these columns, because that's another thing we talked about. We know that we can use names in named objects, and in this case it would be like that. If we run that, we get a matrix, again, all of the rows and just the 2 columns that we wanted. Okay, so far so good. Looks like every time we subset a matrix we get a matrix. However, it's not always the case. So let's look at another example. Let's say we want to extract games, and we just want to extract the first row, just Kobe Bryant. If we say 1 comma blank and we run that, we get something similar, something that looks like a matrix but not quite. So if we compare it to this matrix here, you can see that this matrix has row names. This matrix doesn't. Why is that? And is this a matrix in the first place? Well, actually it isn't. And we can prove that if we simply run the isMatrix function and we take this, our new object, and we put it in the isMatrix function, we check. We get false. Why is that? Well, because it's actually a vector. If we check vector, isVector, we get true. Interesting. Okay, let's have a look at another example before we explain that. Let's say we want games and we just want one value. Let's say we want Kobe Bryant, so the first row, and for 2009, so the fifth column. We would go games 1 and 5 and we run that. And so we got the one value, but it's not a matrix for sure. It's a vector again. So what is happening here? Why are we getting vectors instead of matrices in these two cases? Well, what's going on is actually the square brackets have this specific quality to them, which a lot of our users might call a flaw, but in reality, it's just how the language was designed. So what is going on? Well, R is trying to guess what you want. So in all these instances, obviously you want a matrix because you're getting a two-dimensional object. But here and here, your object is no longer two-dimensional. So R thinks, well, maybe what you were after was actually a vector. And it returns you a vector. So in this case, it's a named vector. It's got the elements are named. In this case, you just get a vector of one value, 73. And why does R do that? Well, because let's remember that R is not just a programming language. It's a language for statisticians and mathematicians. And there's always going to be this trade-off between programming and following strict rules and procedures and fast, agile analysis of data. So in this case, R is guessing that in most cases when you would want to extract a one-dimensional object from a matrix, you would want a vector. You wouldn't want a matrix. So that's why it's doing that. How do we fix that? Well, to get the default behavior of the square brackets, and by the way, the default behavior of the square brackets, and probably default is not the best word. The best word here would be to get consistent behavior from the square brackets, there's another parameter that you can specify. So in order to get to that parameter, you need to add another comma. So this is your rows, then you've got comma the columns, and then there's a parameter which is called drop. And drop by default is set to true. So what it does is, you can see here, is delete the dimensions of an array which have only one level. It drops unnecessary dimensions. So by default it's set to true. Let's set it to false. If I run this now, you will see that now I have a matrix instead of just a vector like I had here. And what's going on is that R is no longer dropping this dimension. So R would drop any dimension where it's only one. In this case, Kobe Bryant is the only row, and R would just drop that dimension and turn this vector into a matrix into a vector. So here, I can do the same thing. If I say drop equals false, I run that, then I get the consistent behavior from the square brackets, and I get a matrix. So if you type in drop equals false, then the square brackets will always return the same class of element or object as you had originally. In this case, we had a matrix, so we're getting back a matrix. Okay, so that is how subsetting works, and it's important to know about these things. Just remember that whenever you're using the square brackets, R will try to guess what you want. If you don't want R to guess, then don't forget about this let's call it a secret argument that you can pass to the square brackets called drop. And if you set it to false, then you will get the same class of object as you had originally. Hope that's useful, and I'm sure that one day this knowledge will come in handy. And now let's move on to the next tutorial. I look forward to seeing you there. Until then, happy coding. Hello and welcome back to the course on R programming. Now that we know everything about subsetting, let's try using subsetting to change what we're visualizing. So what we're going to do is we're going to copy some of the code that we used in the previous matplotlib tutorial. So let's take, for instance, this bit, because that's our visualization part, and we'll create a new file, and here we'll copy it over here. So what we're visualizing here is field goals divided by game. So let's simplify that and let's just visualize, let's say minutes played, right? And now if we run that, we will see our visualization here. So that's how many minutes the top 10 paid players have played over the past 10 years. Now, let's say we want to subset it. Let's say we don't want to see all of the players, we want to see just the top 10 players. How would we do that? Well, this is our data and we would just replace it, right? Here is our matrix. So let's just pull it out. Let's say, let's replace this with data, and here we'll have a variable for data. That way we can manipulate it easier. We'll call it data and we will say minutes played. And here we will say we just want the first to the third and all of the columns, right? So if I look at this, if I run this line now, and then if I just look at data by itself, that's what we're visualizing. So that's the new matrix that we're passing to these two lines. And what's going on there is it's been transposed. So it's been turned into that matrix. And then it's been visualized by this line. That's the matrix. And now we're going to put the legend. But once again, with the legend, we also want just the first three players, right? We don't want all of them. So here we need to say players 1, 2, 3, because that's a vector and we just want to extract the first three players. So if we run this line now, then we've got a legend here, which is good, right? So that's how many minutes each of the players has played. And once here Kobe Bryant was injured and here he was injured again. And probably that's also an injury. Usually on these charts, when you're not normalizing by the number of games they played, if you see like a drop like that, usually that represents some kind of injury. Okay, so that's the minutes played for the first three players, and that's an example of how we are using subsetting already in our analysis. Okay, let's say we don't want the first to the third players, but let's say we just want to visualize Kobe Bryant by himself, just Kobe Bryant. So we would say 1 here, and we would also say 1 over here. Right, so let's see how that works out. So that's our data. Now we're going to run matplot, and all of a sudden there's a problem. What's the problem? Where is the problem coming from? Well, let's have a look at the data object. If you look here, you can see that it's no longer a matrix. It's actually a named vector. And why did that happen? Well, that's because of how subsetting works, something we talked about last time. What it's doing here is it's guessing what you want. It's saying that because you're extracting just a one-dimensional object from matrix, probably you want a vector, but we don't. We want a matrix because matplot requires a matrix. So what we're going to do here is we're going to use our little sneaky trick. We'll say drop equals false. And if we run this now, and we run matplot and legend, you can see that Kobe Bryant is his minutes played are being represented properly. So there you go. That's a live example of why it's important to know about subsetting. And it's also important to know how these square brackets work, what they return, and what exactly you want in a specific situation. In this situation, we wanted a matrix, so we used the drop equals F tool. And that brings us to the end of today's tutorial. I look forward to seeing you next time. And until then, happy coding. Hello and welcome back to the course on R programming. Today we've got a very exciting tutorial because we are going to create our very first function. Up until now we've only been using functions, but today we're actually going to create one. So let's see how this is going to happen. What are we going to create a function for? Well, you see this bit of code over here that we're using to visualize our data. It happens to be that we're always copying it along. We're always dragging this code along whenever we want to create a new chart. So we had this code here, right? We had this code here, and now we have it here. So whenever we want to create a new chart, we have to copy this code along. And how about we find a way to encapsulate this code in a simpler form so that whenever we want to create a chart, we don't have to type up all of this code again or even copy it. We just call that simpler form. And that's exactly what functions are for. Functions are designed to encapsulate code that does something in just one object inside the function itself. And then instead of typing this code up every time, you can just call the function and pass it some parameters and the code will work. All right, so that's exactly what we're going to do. We'll do it by steps so that we don't get overwhelmed. We're going to start by just encapsulating all of this code. So let's create a function that visualizes minutes played for different players. So we don't need this over here. We're going to encapsulate all of this inside a function, right? So how do we create a function? It's actually pretty straightforward. It's very similar to the structure that we had for loops, like a for loop, a while loop, and so on. So let's check it out. To create a function, you type in the keyword function, then you type in normal brackets, and then you type in curly brackets. And you put the code of your function, the body, into the curly brackets. And there we go. So that function is pretty much ready. What we need to do now is we just need to assign it a name. And to assign it a name, you just type in the name before. So let's say my plot, that's going to be the name of a function. And then you put the arrow. So basically, my plot is the object, and inside that object, you're going to put not just like a value, a vector, or a matrix, you're putting a function. So a function is also an object in R. And now if I run this code, I have a function, my plot. So if I look here, you'll see it here, my plot function. And now if I just call my plot and run it, what it'll do is it'll actually create this visualization. Now we didn't see anything happen because it's the same visualization. Let's change the player that we're visualizing. Let's say we're visualizing the second player. Let's change that here, and let's rerun this function. And now let's execute it. As you can see, the function has changed. Now the color hasn't changed, but that's because that's how a legend is designed. The top player will always, in our data set that we're visualizing, will always have this color. So if we visualize, let's say, the second and third players, right, like that, if we run this function again, create it again, and we visualize it, now we have two players there. Okay, that's good. But as you can see, every time we want to change the players, we have to go back into the function and actually change these values to the players we want to visualize. Now, we don't want that. We want our function to be flexible. How do we do that? Well, in order to do that, we use parameters. And we've already encountered parameters numerous times when we were calling functions like sequence or replicate or rnorm, any other functions that we've been working with. Most of them actually take parameters. So how do we specify parameters for our function? Well, it's also pretty simple. Here in the brackets, you need to specify the parameter name. So let's call our parameter rows. So which rows do we want to look at? Then all you have to do is copy this in the place of where you want that value to go. So we want it to go here, and we want it to go here. So now we've got this variable, right? So rows became a variable, and when whatever value we put in here, the function will automatically look for that word throughout the code, and it will replace it. It'll replace it here, and it'll replace it here. It's as simple as that. So if I run this now, if I create this function, and then for my plot, now I supply it some variables. Let's say I say the first to the fifth players. What the function will do, and this is the important part, the function will take this value because it'll see, aha, I'm looking for a value. There, the user is supplying me a value. It's supplying me a vector. So I'm going to take this word rows, and everywhere where I see rows inside the code of the function, I'm going to replace it with the value that's been supplied. Okay, so let's try that out. As you can see, it's beautiful. We have the 5 players visualized. Awesome. Let's try a different one. Let's say players 1 to 10, all of them. See, now we have all of them. Okay, so we're nearly done with the function. The last thing we want to do is we want to use this function to visualize other data sets that we have. Right now, the only data set we're visualizing is minutes played. And if we wanted to change it, we would have to go in here and change this to games, right? We would have to go in, and then we would have to run this code again, recreate the function, and then plot. And now we see the games they've played. Or if we wanted to visualize the points that they got for their teams, now if we run this code again, we can visualize the points that they got, right? So you can see that every time, once again, there's this moving bit in the function that we have to change, and that makes the function inflexible. How do we change this? How do we make the function flexible? Well, it's pretty simple. All we have to do is, once again, create another parameter. So let's put one here. We'll put it first because it's more important, and we'll call it, let's call it data. So now we're saying that we want a parameter passed to the function, which is data, and wherever in this code we see data, we're going to replace it with the value that's going to be supplied. So here we're going to replace points with data, And so whatever is going to be supplied as data is going to be replaced here. So if I execute the function, I create the function, and then here I need to supply the data. So let's say I want to visualize salary for all 10 players. If I run that, you will see that now we see the salary for all 10 players. Once again, I can change the players I want to visualize 1 to 2. All right, so that's beautiful, isn't it? We're visualizing exactly what we want. And the final bit, the bonus bit on top of everything, is we're going to set a default parameter. You know how sometimes when we're using functions, they have default parameters already? Well, this is exactly what we're going to do now for our function. We're going to say that rows will have a default value. The default value will be equals 1 to 10. So if the user doesn't pass a parameter for rows, we want to visualize all of them. So let's see, let's try that. Let's create this function like this now. And now we're going to visualize it, right? So instead of actually putting in the row numbers that we want to visualize, let's say we just don't put the row numbers in and we run it. As you can see, the function has now visualized all of the rows for us. And that's exactly what we were after. Okay, so that makes this function very flexible. Now you can set any data set and any rows that you want, and you don't even have to set the rows. So you can type in minutes played, right? And you can run it, or you can type in minutes played divided by games, because we know that a matrix divided by a matrix is a matrix, and we run that, we visualize all of the players. Or you can look at certain players, so let's look at the third player. You can see that that's how many minutes per game LeBron James has played in the past 10 years. All right, so that's us creating our function. It was a step-by-step process. I hope it was quite clear what we were doing. And now we have a very useful function that we can use in analyzing our data set. So we will get to that in the next tutorial, and we'll drive some very cool and interesting insights from this NBA basketball data. And I look forward to seeing you then. Until next time, happy coding.